All right, guys. Good morning from Ghana. Uh, yeah. So as I promised, I said that I'm having a lecture series with it's actually a 5 day lecture with a department in University of Energy and Natural Resources in Ghana, and in collaboration with their robotics team. So I actually plan to make this as practical as possible. So the main topic is to teach Arduino programming, right? But I also want to use this as an opportunity to also show how you build devices using Arduino. And as a project for this program, I decided to build something very simple. Uh, Technically, I'm building a board that we'll be using during the programming phase to learn how to program. So we're building a very simplified or a model of a traffic light, just across a T-junction or a crossroad traffic light. But then I would be adding other things, okay, not necessarily pertaining to traffic light, but so that I can teach certain concepts in programming in Arduino, okay. So the class started yesterday around 6:30 p.m. GMT. That's Monday on the that will be 13th. Yeah, that will be 13th. And because I want to be able to finish what I wanted to do, and we don't have enough time during the main class session because it's just a 2 hour period. What I've decided to do is to do an off-class session where I'll be designing the PCB, okay, the actual circuit, because I have to get this ready by tomorrow so that I can start using it to teach the programming aspect, right? So yeah, that's what I'll be doing mainly in this session, and also for a kind of show some, talk more into the things that I explained, and then maybe show samples of the components I've been talking about and all that, because it's actually difficult doing all of those things during the actual live session. Okay, so these sessions will be recorded, and I've also shared the link in case you would like to join the live session. You can always follow up, okay, and then we do it. So right now, I'm going to start designing the PCB up to where we ended yesterday, and also talk about a couple of things that probably might not be clear, and also expand on other things. Okay, so if you are ready, then let's get started. So yesterday we started talking about some fundamentals in electronics, and we started doing this project which I call Project Joyce. Okay, so what we've been able to do so far is, remember I said something that in electronics we are the job of a circuit designer is simple. So there is a load that needs to be controlled or turned on or powered, right? And there is a power source that we need to move to this load. Now, our job as circuit designers is to move this load from the source to the move this energy from the source to the load as efficiently as possible, and also design circuit or control system such that the load can function as we intend to. Now, if you look here, because we are building a traffic light, our load is mainly going to be the LED sets. Okay, so we have this for red, this for amber, and this for green. Okay, and yeah, we may do some adjustment on this, but for now, yeah, I'll leave it like this. And our power source will be coming in through this. Okay, this is a DC barrel jack. So I'm quickly going to show you the components, images of the components that we have used so far. because I brought some with me here. So let's start with the switch. That's the switch that we are going to. Okay, this switch, or probably, yeah, let me pull everything down so that I can easily access them. All right, so I'm going to move all the components. We have the DC barrel and the DC barrel jack. Okay, and then we have capacitors. We have the switch, and then we have resistors, and we have LEDs. Okay, we have LEDs. I'll show you very soon, don't worry. Just trying to get all of them at once. Okay, yeah. So yesterday, so far, the components you have used, okay, so the DC barrel, that is this, okay. See if the system can zoom in. So this is the DC barrel, okay, this component here. Let me see if I can zoom in. Well, okay, so this is a DC barrel. That is where we would input our power, okay, and we'll be inputting the power using this connector. So this will join to that, okay, to bring power from whatever battery source that we or energy source that we'll be using, okay. Then right from this, it will go through this switch, okay. So this is a switch, okay. So this is what we will use to make or break the circuit. Then from the switch, we have capacitors. And yesterday, I explained that these capacitors are serving as temporary energy or temporal energy storages. Okay, we need these things, one, to smoothen out the power coming in, and also we want, batteries or the energy source we may be using may not have the tendency of discharging faster uh, to the pace at which our circuit may desire energy. So putting a couple of these together serves as a buffer and a power buffer for our circuit, so that our circuit can actually get energy as fast as possible. Now, this is a typical example of this is actually an electrolytic capacitor. Okay, and yesterday I mentioned that these capacitors are polarized. That is, they have a distinct positive and negative terminals. You cannot just connect them anyway in your circuit. Now, if you look at this, you can see that one terminal is actually longer than the other. Okay, so this longer terminal is the positive terminal or the anode, and the shorter one is the negative terminal or the cathode. All right, and we have used LEDs. Now these things here are all LEDs. Okay, they give lights in circuits. These are all LEDs, and you can see that they come in different colors. Okay, in my hands I have red, green, blue. Okay, there are others, yellow and stuff. Now they also come in different sizes. These ones that I'm using right now, they are 5 mm. Okay, they are 5 mm LEDs. You can also get 8 mm, 10 mm, 3 mm and other sizes. Now these ones are actually colored. Okay, these LEDs are actually colored. um, there are others that are not colored, like these ones. Okay, these ones, they are not colored, but then when you switch them on, they may give a particular color. Is that okay? And for our traffic lights, we are going to use these clear ones for them. Okay, we will use the colored ones for other things like onboard signal indicators and stuff. Okay. Okay, so this, okay, and I have another kind of LED here. I can see that this one has 3 terminals. Let me see if I can zoom in. Yeah, so you can see it has 4 terminals, right? This is called an RGB LED, RGB, red, green, blue LED. So this single LED can give the three primary colors or primary lights, red, green, and blue, right? And then because they are all contained in one thing, I can actually use the microcontroller or code to mix various intensities of the red, green, and blue to get other colors. Okay, so this is a typical example of an RGB, and I'll be mounting one of these on the board so that we can use it to program our circuit. Okay, so those are the things that we've done so far. Oh, and one final thing, we also used a resistor. Okay, I don't have one closer to me at the moment. Steve, look, check. There should be a resistor container over there. Can in my bag first. In the box. In the box. All right. So I'm here with Steve. He's an electrical technician and also my brother, of course. Yeah. So if you see him around, he's still there. It's in a pack, a rubber pack. No, a plastic container. All right. Just a minute. Okay, so I have a resistor pack here. Okay, it's a resistor kit actually. There are different values in it. Okay, let me open and show you. All right, so this is how they look like. Okay, is the resistors look like. Now, resistors come in different sizes, and I'll be explaining in this particular of class session how to choose your resistors. Okay, and what informs the decision in choosing resistors. Okay, so these are the components that we have used so far, and so we're going to start building the circuit, the PCB. Yeah, that's the physical board for it. Okay, for them so that we can progress at a faster pace and finish up with what I want us to do. Okay, so everything I showed you so far. Okay, so the power barrel, DC barrel, the switch, then the capacitors being used as storage. Okay, so in here we are using their circuit symbols instead of the actual pictures, and then we have strings of LEDs. Now, I said yesterday that we are going to use a power source that is 12 volt. Okay, our power source is 12 volt, and to judiciously use the energy, not be wasteful, we are serializing for the red LEDs, we are putting them in series. Okay, so if you look here, uh, every red LED requires or a forward voltage drop of 2 volts, right? So that means if we can actually put 6 LEDs together, 2 volts each, that gives us a total of 12. But then I explained that sometimes your power source may not be very accurate because there are instances where you charge a battery or a battery will be rated 12 volts. However, when you measure, it may be 13 plus or if sometimes 14. And if that happens, that means this LEDs would all burn out. Okay. So in order not to do that, we are replacing one LED with a resistor so that this resistor serves as a protective resistor. Okay, so in total, the 5 LEDs will take or consume 10 volts out of the 12. That means that this LED that we put here has to handle the 2 volts excess. Okay, and so we have one serial line, another connected parallel. We will be arranging them together. Okay, we'll be arranging them together to form the red LED. And we also have this something similar for amber and something similar for green. Now for amber requires a forward voltage drop of about 2.1 volts, right? So putting 5 together still gives us 10.5. That means the LED for amber, the resistor for amber would have to deal with 1.5 volts instead of 2. Now, green actually requires about 3 volts. It has a forward voltage drop of about 3.1 volts, right? So if we put 5 together as we've done here, we would exceed the 12 volt, because then we will need about 15 volt to turn on all the 5 LEDs, right? So in order not to do that, we are rather serializing 3 of them, which gives us a total of 9, and then we will use this resistors here to actually serve as protective resistors. Okay, so yes, this may not be efficient, but then mostly, yeah, there is always going to be a trade-off when you are building circuit. Okay, now take note that I'm building this circuit in steps. So probably if you're already a guru in this, you may be looking forward for me to do something, and I may not be doing it at the moment. Yes, please just uh, relax. I would get there very soon. Okay, so it seems the online session is off. Please just a moment. Let me put it back. Okay, so yeah, great. Now I'm going to do a few housekeeping stuff. Okay, so this is supposed to be for red, and you see that I duplicated them for this. So let's quickly how I wish there was a way to change all these names at once. Okay, so I'm going to do this for amber. Okay, and maybe let me just get rid of this instead of trying to and then duplicate instead. That I think would be quicker. 1, 2, 3. Okay, so we need one more for amber. Okay, now let's wire it up. And remember, I said the green, when you see the green lines, think of a wire. Okay, I'm actually physically connecting them together. Okay, so let's get rid of this, and then let's call this R amp. Okay, actually we set a value to it. We will do the calculations later. But do the calculations later. Okay, so now duplicate and then duplicate. That's good. I'm going to do the same thing for this instead of yep. Okay, so this will be green. Okay, this will be green, and then I'll get rid of this ones, duplicate this here and there, and then make the connection. I actually haven't calculated how many LEDs you will need to make each of them. Okay, so for now, just try not to worry too much about it. Okay, we will definitely figure it out. Okay, and we put this here. All right, so I think we are good. We are good, and also we would actually. So this is RGB, right? This actually forms just uh, one section. Okay, so just one module. Okay, so we will need to duplicate it. In order not to have a very clumsy PCB, let's just keep this for the meantime. Go and do some of the routing. Go and do the arrangement, and then you can come back to this. Okay, all right. So what we have here are called schematic libraries, right? But we want to actually develop the physical PCB, which is the physical board that we can arrange the components on. And to do that, we need something called footprints. Okay, we need footprints. So before I can actually do this footprint thingy, we have to first annotate and assign all these components unique references. Okay, so to do that, come to this point and say, click on this, say annotate, right? So now you can see that instead of DDD throughout, now we have D1, D2, D3 like that. Okay, so this D6, D7 labels are unique names that have been assigned to each component so that the software can actually work with them. So if you look here, too, you can see C1, C2, C3, C4, right? S1 and all that. Now, the next thing we have to do is to associate physical footprint. The footprint is mainly how the device looks like, okay? How the device looks like. So we click this icon and that should open a footprint editor. The footprint assignment or association window is actually loading on my other screen. When it is done, I'll move it. Okay, so it's loading. Yeah. So if you want to learn how to use KeyCard, I actually have a course online, some video sessions online. Okay, so you can link up. Unfortunately, that session is not free, but it doesn't cost much. Okay, so if you really want to learn how to use KeyCard, please get in touch or get into my DM, and then I'll show you how you can get it. Okay. All right, so it's loading. I'm doing quite a lot on my PC, so the memory is kind of used up. Okay, just some few seconds. And of course, the first time you open this is going to take time to load, but afterwards it doesn't take that much time. Okay. Okay, so it is done loading, and as you can see over here. Okay, so these are all the components we have used so far. So what you're going to do is we are going to assign footprint. The uh, footprint holds like the physical form of the component, right? So let's start with the capacitors. The capacitor that I have, Steve, can you grab me a ruler? There is a ruler in the box. Okay, the capacitor that I showed you, the electrolytic capacitor, so it's a true hole. That means when we say the component is a true hole, we have to drill a hole in the body in order to push it through, right? So that's where you find them, capacitor THT. That stands for capacitor through hole, right? So I'm going to click on that and then try and also put some assistant views here. So I'm going to put this view will help us to see how the component that we are choosing, and some components do have 3D models. So I'm going to bring up the 3D model. I'm going to put a pane where we can see the 3D model of our components. Okay, so the first thing we want to choose. So if every physical component has some dimensions, right? So I'm having a rule, and what I'm doing right now is to measure the diameter of the capacitor, and what I have is actually 1 mm or 10 millimeters. Okay, and the height is 17 millimeters, and the space between the pins, which we call the pitch, is 5 mm for the component, the capacitor that I'm using. So that is the information I'm going to use to select. Okay, so when you come here, you can see length. Okay, we want a length of about 17, 18, but not this structure. We want something that is radial. Yes, very good. The diameter I want is 10, right? So you can see that there are various uh, various diameters with 10. However, their pitches are different. Okay, so you can see that there is one that is 10 mm, which is the size I want, and the pitch is what, 5. However, this is not the footprint I need, so that's not what I'm looking for. Fantastic. So here we have 10 mm diameter and a pitch of 5, which is exactly what I want. Now, usually the height is not something you would want to worry about unless you are probably designing to fit a particular enclosure. Then yes, you may have to consider these things, but for now we will just select this. Okay, now one thing about keycard is that I can actually hold control and select all the components and then select a footprint for them at once. Okay, now the next thing is the LED. Also, again, the LED that we are going to use is the through hole. That means you have to drill a hole and push it through. So we go through the library, the footprint libraries, and look for LED. Now you can see that we have LED SMD, surface mount device, and LED through hole. So what we want is the through hole version. So let's select that. Now I mentioned earlier that our LED is so you can see that we have different sizes, right? 1.8, 3 mm, right? But what we want is a 5 mm LED. Okay, so I'll go ahead and choose it. Oh, and there are other colors, right? So probably for the red, I can decide to take these guys. So holding this, hold shift to select everything, and then select all of this color for all of them, right? The amber, well, there is not a default amber, but I think I have designed a library for that. So I mean, you can just go ahead and choose this for the amber to choose the same color for the amber to, not as if it matters any way, right? But then if you still want to be very distinctive on your 3D model, then you have to probably look for the 3D model, and you can find the 3D models online, right? You can find them online. There are sites that can give you the 3D model. We have GrabCAD, we have 3D Content Central. You can find 3D models there. But let me see whether I have different colors in my library. Electronics, where are you? Oh, whoa, where is my, okay, so electronics. Okay, so you can see I already have my own amber LED, right? So I'll go ahead and use that for it. Okay, so amber, and then the green too, I'm going to use my green LED, right? So like that, select for that. Okay, so we've associated the physical footprint, okay, for the that. Now J1 is the power, what do you call it? The DC barrel. And I'll choose that too from my library. There is DC barrel and keycard library, but I have associated a 3D module with mine. Okay, so not to waste time, I would just associate this like that. Take note, this is not supposed to be a keycard class. I have sessions on that, so you can get in touch if you want to learn them. All right, now the resistors. Now back to the resistors. Remember, I was talking about the fact that resistors come in different sizes, right? So let's bring up some search. Okay, so I want Google. Okay, come on, why? Right, let me just quickly turn off something. Okay, so resistor sizes. Okay, just quickly want to show you something. All right. Okay, so this is something called a surface mount resistor. Okay, we won't talk about them now. Okay, so this is a typical example of a through hole resistor. Yes, so these resistors actually do have different sizes, and the size of a resistor is actually proportional to the wattage, okay, the amount of energy it has to dissipate. Okay, so you can get something like 1/8 watt resistor, and it has a body length of that and a diameter of that. Okay, you can have a quarter watt resistor, a half watt resistor, 1 watt resistor. So for the same resistance or for the same resistor value, you could actually have what do you call it? You could actually have different sizes for the same resistance value. Okay, so let's say if I'm working on an application and I need something like 100 ohm resistor, I can get 100 ohm as a 1/8 watt, 100 ohm as a quarter watt, 100 ohm as a half watt, 100 ohm as 1 watt, 100 ohm as maybe 3 watts, and so on. Is that okay? So aside choosing the value of the resistance as we'll be doing for this, okay, by applying Ohm's law, let me just pull up a calculator. Okay, so let's quickly just use Ohm's law for this. Okay, so we know that we are applying a total of 12 volts across this series, right? And out of this, the total, all this LED will consume 10. Okay, together they will consume 10 because each will take 2. That means that the excess voltage that we need the resistor to handle will be 2 volts, right? Which is obtained from 12 minus 10, right? So the excess will be 2. Now, these LEDs can actually take LEDs, you drive them at with a current of 20 milliamps, okay? But then we don't want it to stay that bright. So we will drive these LEDs with a current of 15 milliamps. Now, since these LEDs are in series with a resistor, it means that the same 15 milliamps that we want to flow through these LEDs will flow through the resistor, right? Now, power is given by the product of voltage times current. And here we are talking about the voltage that is dropping across the resistor and the current flowing through it, right? So we can actually calculate the power of the resistor that we want. How do we do that? So we know that a current of 15 milliamps. Now 15 milliamps will be 0.015, okay, amps times a voltage of 2. So you see, we need just what 0.03 watts, which is not even up to 1/8 watt, right? 1/8 will be 1 divided by 8, which is still bigger than what we need. 1/8 watt is going to be 12 0.125, but the power rating of this resistor as we need it to be should be 0.03, okay, or 30 milliwatt. Okay, good. However, my rule of thumb is usually if you calculate the resistance, the power, and it's let's say 30 milliwatts as we have here, don't use exactly 30 milliwatts. Use at least twice that value. So even if we multiply that by 2, that will give us 60 milliwatts, right? Which is still not even up to 1/8 watt. But then the resistor set that I have with me is let me see, looking at it, it's yeah, it's a quarter watt resistor, right? And that is what I have to, even if I want to use 1/8 watt, I can't get it anyway. So we're going to use a quarter watt resistor for this, right? And so if we go back to our online thing, a quarter watt resistor has a body diameter of about 6.5 mm, okay, body length, right? And then the diameter is 2.5, okay, and the lead is that. So if we come to key card, our footprint selector, okay, let's get rid of this for now. Yes, so when you come back here and go to resistors, and again when you come to resistors, you should find two versions, SMDs and through hole. We are working with through hole, something that we have to drill a hole and push it through, okay? So for our resistors, we need a quarter watt resistor, okay. We've already checked the dimensions and you can see that there are various shapes, okay, but we want something axial in nature. So axial and horizontal, So yeah, you just have to look for it. Let's see, number. Yes, so we need something, we want to mount it like this, right? But then let's look at the dimension. Okay, so 2.5 is good because over here, okay, you can see that the quarter watts, the body length is 6.5, okay, and for this body length is 6.3. The diameter is about 2.5, okay, and the pitch, that's the space between the pins, about 7.3. Now, technically, we can actually use this, right? Or if we want something that would spread out more, well, we can use that. Now, I don't want to use this because, I mean, that means it's going to take too much space. So I will just go with these ones. Okay, so I'll select all my resistors, click and hold shift, select all my resistors, and then choose the one I want, which in this case would be that, I think, 6.3, 2.5 years. So this is the value, the footprint that we want to use for this resistor. Why is it not showing? Okay, so this is the footprint. Okay, so this is how we also mount it on the PCB. This is what we call the footprint, and it actually coincides with the actual size or the physical size of the resistor. All right, so good. Now finally, yes, so you can see we also have a switch over here. This is not the one that we are using. That's not the one that I brought. Okay, so we have to change it. But before that, let me see if I actually have it in my library. If we don't have it, then we choose something from keycard. So what switches do I have? Hmm. I don't think okay. I think this would be it. Yes. Let me take measure the dimensions. Uh, Switch, where are you? Oh, come on. I just used that thing. Sure. Okay, so yes. Looking at this, let me see. Can I measure the diameter? The pitch from here to here. Okay, so there is a ruler here. From here to here is 4 4 mm, right? So I have to physically measure that and be sure. Actually, the one I have is not 4 mm. It's about uh 6.5 mm. So that is not what I'm looking for now. Take note that if you select a wrong footprint, you would end up discarding your PCB, okay? Because then the components is not going to fit. All right, so let's go to keycards libraries and see if we can get a switch for ourselves. So we need a switch. We need a switch. Where are you? Hmm. We need a switch. Switches. Uh, do we have to model one? No. We cannot do that. Oh, come on. Should have a switch. Okay, it looks like I don't have a switch. How come? No, there should be a switch. Switches. Okay, button switches. No, not looking for button switches. Not looking for button switches. Okay, let me turn off this selectors and see if we can get more switches. No, all these are button switches. Okay, there should be a switch. There should be a switch. That is interesting. Okay, sometimes just have to take some time. each channel path. All right, I think there is no, the switch I'm looking for is not in here. Okay, so what I'll do is I'll look for it later. Okay, so not to waste your time, I'm gonna look for it. I can actually design it anyway, but like I said, this is not supposed to be a keycard lecture uh, class, so I'm not gonna do that. Okay. All right. So yeah, we don't have the switch. So maybe just for the time being, let's assume we want to use this. Okay. Okay. Let me try one more time in the electronics library. Electronics switch. All these are push switches. Hmm. Nope. Nope. Okay, so I actually don't have that switch, that kind of switch. Yeah, so I'll get it. If I don't get it online, I would design it. Okay, I'll design it. I'll have to look for its name anyway, so don't worry. So for now, let's just assume we'll be using this particular one. Okay, so yeah, so you can see that we have now assigned footprint to everything. So the next thing is to apply and save and okay. Now, when we switch back to our schematic, we can now go to another program called the PCB Editor, where we can actually lay out how we want our circuit to look like. Okay, so to do that, you can go to Tools in Keycard and go to Update PCB from Schematic. Okay, so once again, this is going to take some time to load, and then yes, update PCB. Yes, it is. Close this, and then actually it opened on my second screen. All right, so this are all the components, okay, that we have laid out so far. You can see that it has brought them all here. Okay, now KeyCard has a 3D viewer that you can use to view what you have done. So you can see this, everything, the circuit that we have brought in here, just like the 3D view. Okay, so the next thing we're going to do is to take our time to arrange these components. Is that okay? We're going to arrange this component. Now, because we are not done with the entire circuit, I'm not going to create a board for it. Now, I'm just going to arrange the components as and when it comes in, especially the LEDs, right? Okay, so usually what I do is to open the editor and this side by side. Okay, looking at the nature of our circuits, this component, which is the power barrel, I would definitely mount it somewhere here, and then right after it comes the switch. Well, maybe something might change, maybe it might not. I would put the switch to somewhere here. Okay, and then the next after this comes the capacitors, right? I'm not actually very sure whether this is going to be the final arrangement, right? But for now, let's just do something. Okay, so this comes in, the second capacitor comes in. Okay, so if we weren't using this library, this software to do this, then that means we will have to be doing this probably on a breadboard or something, or a perforated board, right? So learning how to use this software really makes electronics easier. Okay, so if you really want to do electronics, then please spend time to learn this software. All right, so this I'm going to arrange our capacitors. Okay, yes, and maybe spend some, I'll orient them. Okay, so hold on shift to select the two, and can right click and go to align them center, select this and that, I click on this and go align, select, okay, and then do the same for this and that. Align, center, good, and do the same for this and that. Align. So I just want to make sure they are perfectly aligned. Okay, perfectly aligned. Okay, now I'm going to group this. So if I click on this now, so that I can move these guys together as a single unit. Okay, I don't want them being to get distorted again. All right, so that for now, let's say that that is what we want to do for our power side. And if we go back to the 3D view, you realize that all the update that I've done would also reflect. Okay, so that's the arrangement I just did. Okay, all right, so now let us arrange the first LEDs. Now we want to arrange these things in a circular form. Okay, we want to arrange it in a circular form. Going to turn off these lines. These lines that you see here, we call them rat's nests. Okay, it shows you how the connections exist between them. Probably let me just keep them. So let's start with the red guy. So this is going to be our first LED. Let's get some circles to be a guide. Okay, so let me see what grade am I operating on. One, yeah, I think I like it. Okay, so let's draw some circles here. I want this on a different layer. Bring up the layer. I want this done, and okay, anyway, I will delete the circles. So let's draw. So this, as you can see, that as I move it, it shows me the. Okay, so let's say the first one should be mm, 7, right? A radius of 6, maybe, right? We don't want some 6 mm. That's too small. So let's make it 10. Yeah, a radius of 10. Radius of 10. Yeah. So now I'm going to try and arrange this the LEDs using this as a guide. I'm going to push the first one in the middle here, and so I can select the two, select this, and then use the alignment to make sure that they are properly aligned vertically. Yes, good. Okay, now I don't want these things to move, so I can press on L to lock it, or right click and say lock. Okay, so lock. So now I can actually move this. Okay, so it's locked, so that I can easily arrange the rest. Okay, so let's arrange the rest of the components. So I'm gonna put this one here, and as you are routing, you should be paying attention to optimizing your route. You don't want these lines crisscrossing. If they crisscross, it means that you're going to have issues routing. Okay, so as you are routing, make sure that you don't have too many of those crisscross. All right, so uh, yeah, but ideally I should probably do a drawing in a good drawing tool like Corel Draw or Illustrator, and use it as a guide to arrange these things. But come on, we are not. We are only trying to do something of a model. Okay, so we are not very bent on accuracy over here, if I may say. So yeah, we will try our best to keep it sweet, but then yep, not particularly concerned about how it looks like. So I'm going to try my possible best to arrange these things in a circular form. Okay, yeah, and last one here. Okay, okay, I think I put it like this. Put it here. All right, so these things do take time. It is actually boring. Like an engineer, sometimes boring is fun. Yes, get this. Trying my best to make it look circular. If it doesn't end up being circular, yeah, we move. Okay, the next one. Okay, so let me move this in here and then try and see if I can align it somewhere here. Okay, I think, well, it looks circular, whether you agree with me or not. Let's look at the Sorry, somebody actually called. Let me put my phone on do not disturb. Okay. Let me see. Probably people when the people are trying to join. So let me bring back. Okay. Just okay. Just a moment, please. See if people are online. Nobody is here. All right. Let me just turn it on. Okay. So somebody is joining. All right. Okay. Let me share. Okay, so let's continue. So you can see that yeah we tried, right? Uh, how many LEDs used so far? One, two, three, four, five. Well, one, two, three, four, five, six, seven. Really? I think I budgeted about 15 LEDs for each. So let's see whether we can actually use 15 LEDs. We've already used seven. So let's see whether we can use all the 15 LEDs. Alright, so we can see that our first round is done. And let's try to fill in more and go this way. Forming this circle is not going to be easy, but let's try our best. Okay, so M to move this, put it somewhere here. Or should I just continue with that? Okay, okay, let's just continue with that. Let's move it over here. Okay, and then let's just hope we can fill up with 15 LEDs because I don't have enough LEDs. Okay, all right, so this guy. Okay, so let's bring in one more circle from the middle, move somewhere here. I doubt we would be able to fill with 15 LEDs, but let's try. There is no harm in trying. Okay, so put this one here. Definitely not. Definitely not. Okay, put this one here. Maybe I may just have to get more LEDs. All right, then the next string. Now be this. Bring it here. The next one comes here. The next one comes somewhere here. Okay, is anyone online? But it's online. Okay. All right. Okay. So yes, we bring the next LED here. Yeah. I think our circle is taking shape. Fortunately, already exhausted our 15 LEDs. My bad. I should have done the calculations. Yeah, but I mean, we need just one or two. Yeah, we need just two more. No, one actually. From here, yeah, we need two more. We need two more LEDs, right, to make it a complete circle. So yes, I think for that we can manage. However, look at something. If we put two more LEDs, if we add two more LEDs, then there is going to be a problem because we only need two to complete this red. That means we have to get rid of three of this, right? So that means the resistor that we choose, instead of dealing with the extra 2 volts as we already calculated, will now be dealing with how do you call it? So these two LEDs will take four, remainder eight. Is that okay? So that means we have to be very careful about the resistor we choose for this. Else these two LEDs will end up being dimmer than the rest or brighter than the rest. Okay, so I'll show you how to compensate for that. All right, so let's as usual, let us annotate it. Yes, because and then we already have because we copied the footprints that we assigned previously is still in there. Okay, so we don't actually have to worry about reassociating a footprint, so we can quickly ship it to the PCB side. Okay, and then yeah, so we brought in two more LEDs. Okay, that means that oh, come on. Okay, so two more LEDs. So this one over there, somewhere here, I guess. And the last one. Oh, okay. So let's see whether we can make it be in line with that. Okay, yes, this place is good. And then over there, yes. And I think be all good, right? So I'm not going to do all the rest, okay, with you online or through this. We will have something like a 3 hour like recording, right? So just want you to know that this is what I'm going to do for the rest of the LEDs. Okay, so let's look at the 3D view one more time. And you can see that yes, our red LED has taken shape, which I think is pretty good, right? So I'm going to do the same for the green and the amber, okay, and then duplicate them for the rest of the other set of light. Okay, so yeah, thank you for watching this. See you at 6 p.m. Bye bye.